All right, so we're going to do our rates of reaction lab. Our experiment 1 is seeing how changing the concentration of hydrochloric acid will affect the reaction rate with a standard set amount of sodium thiosulfate. This is sodium thiosulfate. I measured out 3.16 grams, which you should have already calculated how much you should get. To make a solution here, normally we use a volumetric flask, but 20 ml volumetric flasks aren't incredibly common, so we're going to use a beaker instead. So I have 3.16 grams in here. If I want to make 20 mils of my solution, I'm going to have to add water up to the 20 ml line. So I'm going to add water up to the 20 ml line. Now I'm going to put this on a stir plate. I'm going to add a stir bar and let it do the work for me and stir. So I'm going to let this mix up over here. So now we have our finished solution. So this is our sodium thiosulfate. We're going to be reacting it with hydrochloric acid, which I have here. And we're going to see how changing the concentration of the hydrochloric acid will affect the reaction rate. The way we're going to time this reaction is going to make sulfur. So we're going to time how long it takes to cover this black X, because it's going to turn a yellow color. So we'll vary the concentration of this hydrochloric acid. We'll start off with 1 molar, then we'll turn it into 0.6, then 0.2, and we'll see how that affects how quickly this X gets covered. So my first step is to measure out 5 milliliters of the sodium thiosulfate that I just made. I'm going to go ahead and pour this into here. Then I'm going to measure out 25 milliliters of just 1 molar hydrochloric acid. This is our stock, so we're starting off with the most concentrated one. All right. And you're going to want to start a timer, and we're going to time how long it takes to cover this black X. All righty, 3, 2, 1. You can see it's starting to turn a light opaque, and then that black X is now covered. So stop your timer. So we're going to do this reaction again, but with 0.6 molar HCl, so same amount of sodium thiosulfate, so 5 mils. So I'm going to go ahead and measure that out again. And then I want to dilute this down to 0.6. So you should have done some math already in your pre-lab. I'm going to add 15 mils of the hydrochloric acid, 1 molar. And I'm going to add 10 mils of water on top. I added 10 mils of water on top, so now we have a diluted solution of 0.6 molar. So go ahead and get your timer started in 3, 2, 1. Almost there. All right, and go ahead and stop your timer now. Last one we're going to do is 0.2 molar. So again, we're going to measure out the same amount of hydrochloric acid, or of sodium thiosulfate, so 5 milliliters of that, because that's the variable that we're keeping constant in this experiment. And then we're only going to add 5 milliliters of this hydrochloric acid. We're going to let it dilute it down to 0.2, and then 20 mils of water on top. Right, go ahead and get your timer ready in 3, 2, 1. Go ahead and stop your timer now. So our next part is looking at how temperature affects the reaction rate. So I have a beaker here on a hot plate and a beaker here in room temp. So this is room temperature water. This is water that's warming up. I'm going to be dropping up some Alka-Seltzer tablets in there. I've put them into quarters. What I'm going to do, they have citric acid and sodium bicarbonate in them, and when they hit water, they react. So the two will react together. and make carbon dioxide gas and some salt water. And what you'll notice inside, you'll see some bubbling. So what you want to time is how long it takes for basically the tablet to go away and the bubbling to pretty much stop. So we're going to see how temperature affects that. So the temperature of my room temperature water is 22.3 degrees. This is our water that's been heating up. It's currently at 44.1 degrees Celsius. So I'm going to go ahead and take that off the hot plate. And we want to time how long it takes for it to go away. So this is our colder water right here. This is our hotter water right here. So I'm going to drop the tablets in, and you want to start a timer. We're going to time how long it takes for them to go away. So 3, 2, 1. This tablet's actually already almost gone. So it's done in 3, 2, 1. So this one's done. This is our hot water. Cold water's still going. And we're almost there. You can see there's still a little bit floating around. Still flapping in there. It's almost gone. In 3, 2, 1. And now that one's done. For this last one here, we're going to see how changing the surface area is going to affect the reaction rate. So I have my 2 quarter tabs again. I'm going to break one up into a fine powder using a mortar and pestle. So now you can see that's all broken up into a fine powder. And then with this other piece, I am going to leave it whole. And we're going to time how long it takes for it to go away. So ready in 3, I'm going to go ahead and center these. All right, in 3, 2, 1. You can see obviously the one with the smaller particle size is reacting faster. It's actually almost done here. Give it a little bit of a swirl. All right, and this one is done with the small particle size on the left-hand side. This one's still going. See that small little piece at the bottom there? Almost done. In 3, 2, 1, and it's done. That's our experiment.